This is Lesson 1.6, Relations. Your objectives are to represent relations and to interpret graphs of relations. A relation is a set of ordered pairs. A relation can be represented by a set of ordered pairs, a table, a graph, or a mapping. A mapping illustrates how each element of the domain is paired with an element of the range. The set of first numbers in the ordered pairs is the domain. The set of second numbers in the ordered pairs is the range of the relation. D comes before R, and X comes before Y. The domain is the X, and the range is Y. Express the relation as a table, a graph, and a mapping. For the table, put each ordered pair in each row. 1, 1, 0, 2, and 3, negative 2. There's your table. For the graph, plot each point. The point 1, 1, 0, 2, and 3, negative 2. For the mapping, draw an X bubble and a Y bubble. Don't repeat the numbers in the bubbles, and then draw the arrows from the X to its corresponding Y value. 1 goes to 1, 0 goes to 2, 3 goes to negative 2. Determine the domain and range of the relation. For the domain and range, write them in brackets, least to greatest, with no repeats. The domain is X values. That's your 0, 1, and 3 from the X bubble of the mapping. Your range is negative 2, 1, and 2. That's the numbers from the Y value of the mapping. Express the relation as a table, a graph, and a mapping. For the table, negative 2, negative 1 for the first ordered pair, 3, 3, and 4, 3. For the graph, plot negative 2, negative 1, which is left 2, down 1. 3, 3 is right 3, up 3. 4, 3 is right 4, up 3. For the mapping, your X values are negative 2, 3, and 4. Your Y values are negative 1, 3, and 3, but don't repeat them. Just put a negative 1 and a 3. Now connect them. Negative 2 goes to negative 1, 3 goes to 3, and 4 goes to 3. For the domain and range, use the mapping. For the X bubble, that's the domain, negative 2, 3, and 4. For the range, use the Y bubble, negative 1 and 3. Remember, the domain and range need to be least to greatest, and they need to not repeat. Graphs of a relation. The value of the variable in a relation that is subject to choice is called the independent variable. The variable with a value that is dependent on the value of the independent variable is called the dependent variable. These relations can be graphed without a scale on either axis and interpreted by analyzing the shape. Example 1. The graph below represents the height of a football after it's kicked downfield. Identify the independent and the dependent variable for the relation, and then describe what happens in the graph. The independent variable is time. You can't change time, so it's independent, and the dependent variable is height. The football starts on the ground, and it's kicked, and it goes up to its maximum height, and then it falls to the ground. Example 2. The graph below represents the price of stock over time. Identify the variables and describe what happens. On this one, the independent variable is time. Again, you can't change time. It will go on by itself. The dependent variable is price. Look what happens. The price starts and then increases, then it falls, then increases, and then it falls again. Identify the independent and dependent variables for each relation. Then describe what's happening in each graph. The graph represents the speed of a car as it travels to the grocery store. So we have speed and time. The independent variable will be time. Remember, time can't change. If it can't change, it's going to definitely be independent. The dependent variable is speed. So what happens? Well, the car is stopped and then it speeds up until it hits the main road. Then it maintains a constant speed and flattens out there, and then it slows down and parks. Number 2, the graph represents the balance of a savings account over time. The independent variable is time, and dependent is the account balance. At the beginning, there's already money in the account, and then more money is put in. Then the money sits for a while where it flattens out, and then more money is put in. And finally, all of the money is withdrawn. Pay attention to when the graph goes up and goes down and flattens out. Number 3, the graph represents the height of a baseball after it's hit. We have height and time. Time is the independent variable, and height is the dependent variable. The ball is in the air when it's hit, and then it flies up higher to right there. Then it starts to drop, and it falls all the way to the ground. So for these graphs, remember the variable that can't change, that's going to be the independent variable. The other one is dependent. Pay attention to when the graph goes up and goes down and flattens out. For the first part, remember your relations. A table has each ordered pair in each row. The graph is just when you plot the points. And the mapping has the x values in one bubble, the y values in another, no repeats, and you connect each number to the corresponding number on the other bubble.